Okay, let's pick up where we left off. So far, so good. We'll just have a couple of smaller videos here. All right, so every time we see CH4, holy crap, this is one big story, a story of numbers. We've got what's in it. We've got one carbon and four hydrogens. We've got how many actual molecules we have, and then we broke it up into how many atoms we have. We've got all kinds of math just in that CH4. Now, after a couple of these videos, I'm not going to draw this all out. I'm just going to use those numbers. But I want to do a couple of these and make sure we do them kind of slow so we know what's going on. All right, let's take a break and let's erase some of this and let's add a little bit more to it. In fact, I want to add some percentages. We're not quite done with our story. So let's write out what is in our mole. And let's conserve space a little bit. Y'all, I need like a whole classroom with many boards. I'm feeling really restricted by my little iPad, but we're going to make it work. We just erase a lot more. Okay, so let's write out in smaller writing if I can. Okay, we've got 1 mole here of our CH4, and that is 6.022 times 10 to the 23rd molecules. That is CH4 totally stuck together. And then how much that weighs, we just calculated. That was our 16.363 grams. That is our molecular weight. That is for our CH4, totally stuck together, okay, completely stuck together. And so now that that's together, okay, remember we broke this apart just a little bit more. And we stopped and we said, well, hang on a second. Within that particle, we also have just plain carbon and just plain hydrogen. And for carbon, we have just 1 mole of carbon atoms. And for hydrogen, though, we had 4 moles of hydrogen atoms. And then we went a step further and we said, okay, well, that means we'll have 4 times our Avogadro's number of just hydrogen atoms. Okay, and then how much is that going to weigh? That was our 4 times our molecular weight. So that was, I better draw it down here. What was that? 4.032 grams is how much that weighs. And then in our carbon, we had 6.022 times 10 to the 23rd carbon atoms. And how much did that weigh? That weighed 12. Okay, so now for all of this, and then let's go ahead and highlight our mole ratio. Okay, this is our vocab. From now on, the second you see a formula like CH4, all of this is included in that formula. But let's add to it. Okay, so anytime you see CH4, remember that's up to Mother Nature. That is not up to you. That is not going to change. That is a fixed ratio. We had talked about that in bonding. You can mix 1,000,000 carbons and 1.5 million hydrogens, and you're still going to make CH4. It's just that you might have extras of carbon or extras of hydrogen. It really is up to Mother Nature how that bonding happens. It's not up to you. That ratio is fixed. So that's actually good news because whenever you see CH4, and because they weigh different, these don't change. So if we want to picture this as a percentage and maybe take some shortcuts in our math, let's add one more set of numbers. So if our total molecular weight is 16 grams, out of all of that, which one's heavier, carbon or hydrogen? Carbon. So most of that 16 grams is actually coming from carbon. This will never change. If we put this in a percent, it will be the same whether you have a drop of methane or a bucket full of methane or a barge full of methane. It will always be that same. So let's convert both of these into a percent. Our percent carbon in that total then is going to be our 16. That's our total molecular weight. Well, how much of that is carbon? Just that one weight of carbon. Okay, let's calculate that. Grab your calculator. Let's do the math on that. 12 divided by 16.363, times 100. That is going to give us 73.4%. So every time we look at methane, 73.4% is carbon. Okay, then the rest is hydrogen. Let's go ahead and do the math. Okay, out of that total, 4 grams then is hydrogen. So let's just double check, make sure we did that right. Let's do that math. Divided by 16.363. And I am getting 24.6%. That just doesn't seem right, does it? Shouldn't they add up to 100? Let me double check the first one. Oh, shut the front door. Yeah, that's right. Let's double check it. See, this is why when we have class, you all do the math and I don't. Nope, that only gives us 98%. Let's double check the first one. Okay, divided by 16.363. That is 73.4. Let's double check our math here. Four equals, oh, this is why. Okay, see, aren't you glad we're together? Our molecular weight is 16.043. Aha. Okay, don't go by my memory, that's for sure. Let's fix that. There we go. Now let's recalculate. Shut up right now. I wish we were in class and we were yelling. Now we're talking turkey. Now we got 74.86%. And then let's do the second one. And we are going to get, let's see. We get 25.13%. All right, are we closer to, yeah, let's make that a 4. There we go. All right, are we closer to 100% then? We should be. All right, now these percentages, they don't change. So literally, just pause for a second. Look at how much information comes from just that formula CH4. We figured out 74% of that is carbon, 24% of that is hydrogen. We figured out moles, mole ratio. All of this will now be understood in every one of the molecular formulas that you look at. And now our job is to take these and do some math with it. Okay, so let's stop this one and then we're going to do another one.